Behind the heavy stone doors of medieval cathedrals lies a precise intersection of chemistry, structural engineering, and mass communication. For centuries, Romanesque builders relied on thick, solid stone walls to support heavy roofs. Because the structure required so much mass, windows were kept remarkably small, leaving building interiors as dark, claustrophobic caverns. In the 12th century, Abbot Suger of St. Denis proposed a new theological catalyst, the idea that light itself is a direct manifestation of the divine. To bring that light inside, masons faced a physical contradiction. They had to find a way to remove the load-bearing stone walls supporting the ceiling and replace them with millimeter-thin sheets of glass without the entire building collapsing. Creating the world's most beautiful book required a total reinvention of how humans manipulated raw earth and metal to capture the sun. To create colors that could endure centuries of sun exposure, medieval craftsmen used pot metal glass. Instead of painting the surface, they baked metallic oxide particles directly into the molten glass itself. Sourcing these chemicals was an expensive enterprise. Rare cobalt or powdered lapis lazuli was mixed into boiling vats to yield a radiant blue, often used to represent the concept of heaven. Adding raw copper oxide to the mixture produced a deep ruby red, which was deployed strategically to symbolize blood and sacrifice. Later innovations introduced silver stain, a chemical compound brushed onto the glass that fired into a brilliant yellow, used to render the luminous halos of saints. By mastering these volatile chemical recipes in their workshops, artisans gained the ability to paint using raw, colored light. Shaping these sheets of color required precision with limited tools. Without diamond blades, glaziers applied heated iron rods to the glass, snapped it with cold water, and nibbled the edges into shape using an iron grozing tool. Assembling hundreds of these brittle fragments into a coherent image required a flexible skeleton. Craftsmen used cames, soft, H-shaped strips of lead. They slid the edges of the glass into the opposing grooves of the metal to lock them together. But a flat sheet of interlocking glass scaling dozens of feet into the air acts like a sail. This makes the entire window vulnerable to the pressure of high winds. To counter that pressure, blacksmiths forged heavy iron grids called fermenta. These rigid armatures were bolted across the window openings to absorb the force of the weather. The fragility of the glass demanded a dense, rigid metallic cage working continuously in the background to ensure its survival. Even with the glass reinforced by iron, the primary problem remained. Thick stone walls simply had no space for massive window frames. The solution was the flying buttress, a structural innovation that moved the building's support system to the outside. These exterior stone arches catch the outward pushing weight of the roof, transferring the force straight into the ground. Moving the structural load outside removed the need for solid walls. The cathedral became a thin stone frame, leaving massive voids filled with glass. Gothic architecture is essentially a stone exoskeleton. This engineering solution traded heavy walls for expansive glass panels, achieving structural transparency previously impossible. Once installed, these windows functioned as a visual language for an illiterate population, translating complex theological ideas into immediate, towering narratives. The placement of these stories relied on astronomical timing. Masons aligned specific windows so that on a solstice, a single beam of colored light travels through the glass and hits a specific target on the cathedral floor. Filtering white sunlight into deep, saturated color shifts the building's internal environment. By muting the light and casting long, colored shadows, the windows isolate the visitor from the bright world outside, creating a space for quiet focus. The scale of the hard glass surfaces also created an acoustic side effect. The windows reflect and amplify sound waves, causing monastic chants to reverberate and fill the entire space. Combined with astronomical timing and amplified acoustics, the cathedral functioned as a controlled environment, where architecture and light worked together to guide the viewer's focus. Today, these masterpieces face decay. Atmospheric moisture and pollution trigger glass disease, a chemical reaction that creates microscopic pits and slowly dissolves the ancient material. To halt this process, conservators use isothermal glazing. They install a clear protective layer on the exterior, shielding the original window from the elements while allowing it to breathe. Modern masters continue to use this medium in new ways. This grid of 11,500 colored squares in Cologne Cathedral shows how contemporary artists use the same interaction with light to create precise, data-driven abstractions. A stained glass window remains a fragile, enduring mechanism. It is a combination of chemistry and engineering, designed to pull external light into a dark interior, populating stone walls with images that shift with the sun.